Lesson 1-2, Irrational Numbers. Irrational numbers are numbers that cannot be written as fractions. These include non-terminating, non-repeating decimals. So those are decimals that do not end, that's what non-terminating means, and they do not repeat. One clue in the name irrational is that IR is a prefix that means not. And we still have ratio, which we would refer to fractions as ratios. So ir means not a ratio, not a fraction. Now, rational and irrational numbers are part of what's called the real number system. There are number systems that go outside of the real number system, but we don't talk about that in 8th grade math. That's something you might see in high school. But what you have mostly dealt with to this point are rational numbers, those on the left. If you look in the boxes, the smallest box in here, in the middle, are natural numbers. 1, 2, 3. When you first learned about numbers and you started counting, you counted your natural numbers. 1, 2, 3. After you learned how to count, you later learned about this number 0. That's part of the whole number system. It includes 0, and it includes all the natural numbers. So you might say that there were 0 apples in a bag, or you might have been counting 1, 2, 3, 4, 5 apples. Those are all part of the whole number system. Eventually, you learned about integers. These are numbers like -3, -2, -1. They don't have the decimals, they don't have fractions, but they include the negative numbers, 0, the whole numbers, and the natural numbers that you count with. So these you would consider them to be your counting numbers, 0, and their opposites. And that's most often what you see on a number line. And then we have rational numbers. They do include integers, but they include fractions as well. They include decimals that can be written as fractions. So all these integers plus fractions such as 5/8, they could be negative numbers like -3/7, and then they could be decimals that can turn into fractions. 2.419 repeating is a repeating decimal. We can also include terminating decimals here because those can be written as fractions. Now, on the other side of this real number system, we have irrational numbers. That's what we're talking about today. These are numbers that, if you look at them as a decimal, they do not end, they do not repeat. So this number, 8.1453925 ... It doesn't repeat, and it doesn't end. Those dots at the end mean that it keeps on going. And we're going to talk a little bit today and show how to do these in your calculator. But numbers like square root of 2 and square root of 7, when you type them in, you're going to get a non-terminating, non-repeating decimal like this one at the bottom, 8.1453925, repeating or continuing. You could plug a negative in front of the square root, and it just makes the number negative, but it's still going to be a number that does not end, does not repeat. And pi, you've seen that in 7th grade math. That number pi starts 3.14, but it keeps on going. We just round it when we use pi often in math class. So we're going to talk today about these numbers on the right, these irrational numbers, and also how can we tell the difference? Can we classify a number as either rational or irrational based on these facts? Okay, so we are going to classify numbers as either rational or irrational and give an explanation for that. So let's start with this number 1/3. It's a fraction. We know that fractions are rational numbers. So I'm going to, this is R for rational. We can just abbreviate it. We'll use R for rational and I for irrational. And we know that it's rational because it's a fraction. and a fraction is always a rational number. The next one, square root of 8. Maybe we don't know off the top of our heads if that is a repeating or a non-repeating or terminating or non-terminating decimal, so we're going to go to a calculator. We want to find a square root on a calculator, so we're going to turn on the calculator, and then you'll notice right here in blue that there's a square root symbol over this x squared button. It's in blue, so let's type second square root, and then I just type the number I'm finding the square root of, which is 8. I can close the parentheses. Sometimes it doesn't matter, but it matters on some functions. So if I have an open parentheses, I want to always make sure I close it in my calculator. And then hit enter, and we get 2.828427125. Notice that the digits go all the way across the screen and they're not repeating. So this is going to be an irrational number. So I'm going to label it as I for irrational, and my reason is this is a non-terminating. It did not end. It went across my calculator screen, but it showed as many digits as my screen would hold. Non-repeating decimal. Okay, so we want to find the negative square root of 16. So I'm going to start here with this negative symbol. It's negative, not a minus, so I place the negative because it's at the beginning of a number. And then I'm going to get this square root symbol, so I'm going to type the second function and then press that button. So it popped up the square root with the parentheses. And in that parentheses, I'm going to type in 16, close the parentheses, and hit enter. And it gives negative 4. So since it was negative 4, that is an integer. We know that an integer is a rational number, so I'm going to classify it as rational R, and the reason is it's an integer. Next we have pi, and we can go to a calculator, and I'll show you that in just a moment, but you probably remember seeing pi on the chart. It was an irrational number. You never have to guess at that. Pi is an irrational number. So we're going to go ahead and note that it is irrational, and we will go ahead and see why. Okay, so we are going to see if pi is irrational. So we've got the calculator on, and notice this pi button here. I just press pi and hit enter, and it gives me a decimal 3.141592654, and it goes all the way across my screen and does not repeat. So pi is irrational because it is a non-terminating, non-repeating decimal. It went all the way across the calculator screen and it was not repeating, so it is irrational. Now this would be a great time for you to pause this video if you're watching this at home and try part E and F yourself using your calculator or using the chart. But I will go ahead and show those to you in just a moment. So if you want to pause the video here, and then I'll be right back. Okay, so on E part 2.7 repeating, if you chose that this was rational, then you are correct. It's a repeating decimal. That will always be rational because it can be written as a fraction, a ratio. On part F, if you chose that square root of 2 was irrational, then you were correct. It's a non-terminating, non-repeating decimal. So it will always be irrational.